So I got around to optimizing the Maia3 model so that we could use it to, well, efficiently guess the ELO. And I got it running on a web browser. It can be statically hosted, so like on GitHub pages and so on. And well, it's not perfect right now, but it does work. So I've loaded an example game. And if we press guess the ELO, you'll see that it's going to run inference, guessing the positions and doing some things. At a high level, how it works is it firstly assumes the two opponents have the same ELO and then tries to do a single pass to find, I guess, the average ELO of the game. And then it will do a parameter sweep for the white and the black pieces separately. And then it will just output the final result, which is the ELO of the two players. Now, it's not perfect. Right now, it came up with this score for this particular game. And if I am to run it via the Python way, it does come up with a different answer. I think the Python one is more accurate, and I'll show you why in a little bit. So this is what the Python side looks like, and you can see it ran in 4 seconds. Is much quicker locally on a computer. There's probably some translation issues from the Python to the JavaScript side. So if I look at another game, I have some other games. I'm going to run it on the Python side simply because it runs a lot quicker. So I'm going to run this one, for example, and it's with two lower level players, and you can see that the ELO estimation is very different down here. And maybe just to show you, to compare with like what the chess.com ELO calculations is, I pulled out like 2 random sample games from a lower ELO range. So here in this particular case, it estimated 13,000 and 1,200 as opposed to what the actual ELO is. And then if I look at the estimation, I recorded it in the PGN. We recorded to be white to be 1,400 and black to be 750. So there is some discrepancy. It's not perfect, but at least directionally it's correct, which is actually really cool to see. I'll just show you one more example. So for example 4, we have the actual ELO to be 730 and 690, and then chess.com estimation is 1,250 and 1,000. And if I run the estimate ELO, and I'm going to run it for example 4, it will come up with scores which are very similar, or at least closer than the other ones. So I did run some more analysis, and just to show you what it looks like. Yeah, just to show you what it looks like, I ran it across different types of games that I pulled from Lichess. So you can just download a whole bunch of games from Lichess. And for the 1,000 to 1,400, it got in the range. Yeah, it got these as the ranges, and you can see the relative error and so on. And in general, directionally, it's correct at least. Like for example, under 1,000, you got 890 and 800, and 970 and 1,200, and so on. So directionally, it looks okay. Even for the over 2,100s, it's directionally correct, which is really good to see. Now, from what I've seen, there are some issues, or at least it's not perfect. I think generally white seems to be given a higher ELO than black. I don't think that's on purpose, because even if white was the loser, I've noticed several times that white will still get a higher ELO, even when like the accuracy score that is recorded might actually be higher for white. So there's some tweaking that needs to be done. Maybe there's some kind of like Bayesian kind of idea that maybe you can use to induce like an appropriate score based on the accuracy score. And nevertheless, this was really cool to see. You can see that I have the war times on the left hand side, and it runs pretty quickly, at least when it runs on the computer. On the web, as you saw, it runs a little bit slower. There's probably some optimization from the JavaScript side, but yeah, it's really nice to see that this kind of idea works. It will be really cool to see someone take on a similar idea, or at least extend it, and then maybe one day it'll be available in Lichess rather than being paywalled behind a chess.com membership. Nevertheless, that's what it is. It is guess the ELO with the Maia3 model.